So being able to look at a carbonyl and say, is there resonance involved in this? Is there induction happening away from the carbonyl or towards the carbonyl? Analyzing the difference between induction of OH versus induction of OR. I don't think that would be a test question. I'm just helping you get the framework of why different carbonyls have different reactivities. So can somebody tell me why is the amide so inert, but the acid chloride highly reactive?
Resonance. Can do resonance.
Which one?
Amide.
The amide can do resonance.
No.
So can the ester, so can the carboxylic acid. And you could make an argument that the chlorine has a lone pair that can do resonance too, but for a chlorine to take on a positive charge and make a double bond, probably less likely to happen. So why is it that the amide's resonance stabilizes it more than the esters does, more than the, and I think we did argue that the carboxylic acid and the ester and the amide, they technically all have induction away from the carbonyl carbon. They are a more electronegative atom. They pull electron density away from the carbon. And this is why carbonyls are reactive. This is part of why they are reactive. So they kind of all have resonance to different extents and induction to different extents. So what is it that makes the amides?
Less electronegative than oxygen.
Which makes its resonance stronger. It's less polarizable than chlorine, which makes chlorine more likely to take electrons away from the carbon through the bond, less likely for nitrogen to take electrons away from the bond. Let's run through our carbonyls real quick again. So I want to get them up on the board. From most reactive, no, let's flip it. I'm just kidding. Most reactive to least reactive. Acid chloride. Acid anhydride. Let's see, I'm really not sure how people abbreviate this. I don't think, doesn't make sense as a good abbreviation, does it? Aldehyde. CHO. Ketone. Carboxylic acid. The ester. The amide. And, the one that's not really like the rest of the carbonyls, the nitrile. All right, we had looked at nomenclature for acid chlorides. We said if you took benzoic acid and instead you made it an acid chloride, this would be benzoyl chloride. So you just take a suffix and you modify it, you stopper the suffix with oil chloride. And then we had both a symmetric and an asymmetric anhydride, and I just want to reiterate the symmetric one because what I gave us was acetic anhydride. And the first component there, the ACET, is referencing this group. So you can have acetaldehyde, acetic acid, acetic anhydride. You can have acetamide, methyl acetate, isopentyl acetate. That ACET part tells us a 2-carbon carbonyl. All right. From there, let's move on to aldehydes. I think you guys already know this. What suffix stopper is an aldehyde given? Al. Yep. So, somebody give me a number from 4 to 8. 7. What's the root for this compound? The parent chain. Pent. Yep. And there's a methyl group at 2 of these carbons. Where am I going to start numbering from? Why?
That would be like the lowest numbers.
The aldehyde is the high priority functional group. The alkyl substituents aren't. Even if they were, we would start numbering that direction anyways. But we're going to number so that the aldehyde is position 1. So we'll number from the right to the left. So we'll give this 2,3-dimethyl. Notice that there is no alkene, there's no alkyne, so this becomes pentan. Al. 2,3-dimethyl pentanal. Good? Hope you guys are okay. I want to keep adding some things in. I gave you guys some common nomenclature, gave you guys some prefixes. Now I'm going to start changing the suffixes as well as we go. Ketones. They get the suffix stopper. You guys remember? Own. Kind of interesting, right? The ketone gets the suffix stopper that matches the end of the name. The aldehyde gets the suffix stopper that matches the front of the name. The root here. Not sept. I know, and I wanted to remind you it's not.
Okay.
Wanted to trick you. One of my OCHEM 1 students got that mixed up. Kind of forgot whether it's the Greek or the Latin prefixes. So I just wanted to remind you guys. Hept. Hept for 7. Suffix. No, that's a suffix stopper. Yeah, I mean, you ask anybody else except for John Flood, it's own is the suffix. But you have to, you also have to have "ene" in here. Oh, there's an alkene. What is the stereochemistry of the alkene? Trans, or E. So, which way should I start numbering? What's the priority functional group? The ketone is the priority functional group. So I want to make sure that the ketone gets its lowest locant. 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter which way I go. So in the event of a tie, I move to the next major functional group. That's going to be the ketone, so I'll start from the left. So I get hept, trans, 2-ene 4-one. There's another way you can write this out. You can put the first suffix locant before the root. Isn't it a shame you can't put both of them before the root? Then it would just get kind of muddy and mucky and gross. So, trans 2-heptene 4-one or trans hep2-ene 4-one. Carboxylic acids. Suffix stopper, I think you guys know this one too. Benzene.
Acid.
Oic acid. Yep, close. Notice the similarity between a carboxylic acid and an acid anhydride. They both get the suffix stopper oic acid. And then, of course, in certain instances, the O gets dropped. So you get acetic acid rather than acetoic acid. Don't know that I really have a good explanation for that there. I'm sorry? Does it, though? Does it sound any more dumb than ethanoic acid? I think it's because we all grew up with acetic acid, right? Caesar, do you have a different word for acetic acid in Spanish? What do you call vinegar in Spanish? Oh, not similar at all. Vinegar? Oh, I thought you were starting with a B. Vinagre. Yeah, okay, I see it now. All right, what would you name this? Yep.
I don't think it's propanoic acid, because that doesn't have the alkene.
Okay, so what can you change propanoic acid to? Propenoic acid. Do you need to specify where along the carbon chain the alkene is? Tell me why, Caitlin.
Well, I guess technically.
Oh, she changed her mind.
You shouldn't have to, because you couldn't have the alkene between 1 and 2, but I feel like to make it clear it would just be to say 2, even though technically you couldn't have it there.
Correct. You would break the octet rule if you had the alkene anywhere else along this 3-carbon chain. And yet, the most commonly reported systematic name for this compound is prop-2-ene oic acid. Except I would, in this instance, 100% accept propenoic acid, because unlike trans 2-heptene 4-one, you can't place the alkene anywhere else along the carbon chain. Actually, trans 2-heptene 4-one, the alkene can only be in one other place. It's either 2 or it's at 1. If it's here, it's still 2. If it's here, it's still 1. Then the ketone could transfer as well. Now, I want to give you guys another common name. This 3-body system, 3-body was the wrong. This 3-carbon system is, with the alkene, is referred to as kind of the acrylate family. So this is commonly called acrylic acid. Have you guys heard anything like that before? Acrylate, acrylic, yeah. acrylic paints, right? So there's at least that commonality between the common name and what you've got. Now, some other people might call this acryloic acid, just to make it more fun. And some people might call it ethylene carboxylic acid. I stand by systematic nomenclature. All right, esters. Esters get the suffix stopper. I'm not sure that I gave this one to you guys before, but you might know it, do you? One more time, Caesar.
Is it 08? No.
Oh, 08.
08.
Yep. Plus, they have an alkyl prefix. Whatever is named, or whatever is attached to the ester linkage, has to be named. We're going to bring this up in the next section when we look at carboxylic acids more and their acidity. But the conjugate base of a carboxylic acid is a carboxylate, and the suffix for a carboxylate is -08. So esters and carboxylates. Esters and the conjugate base of a carboxylic acid, they get the same suffix. The only way that you can tell them apart is what the prefix is. So for example, when acetic acid becomes deprotonated, say you mix acetic acid with sodium hydroxide. You have an acid-base reaction that produces sodium acetate. But if you made an ester from a carboxylic acid, then you would get methyl acetate, ethyl acetate, isopropyl acetate, isopentyl acetate. So it's that prefix that tells you, are you looking at a salt complex or are you looking at an ester? It's incredibly important that the ester linkage is named there. Can you guys tell me, as you copy these down, before we name them, what is the relationship between those two molecules? Are they identical, enantiomers, diastereomers, structural isomers, conformational isomers? They just differ by rotating a bond? Or do they have no relationship? Good. The only thing that's changed is the ester has been placed adjacent to the aromatic ring. And so this carbon has moved. I go from having a benzyl group and a methyl to a phenyl group and an ethyl. Okay, so let's name these. What is the ester linkage for this compound? And I understand if that word doesn't quite make sense. I'm not sure that it's in textbooks. It's the way that I think it makes sense to refer to it. What is the ester linkage? So what is the ester? It's all of this, but the part that is linked to the ester that can change is what's attached to the O.
Is that benzonoate?
Not quite. So I want to start with the ester linkage, the OR part, which is greenhouse gases, methyl. Sorry. Just one carbon,
So you don't name the actual oxygen that you're just naming the cut.
Yeah, the oxygen gets named with O8.
Oh, okay, so it's
Yeah, good point. So we're just going to name methyl. And that's why I said alkyl prefix. Rather than, if I wanted you to name the oxygen, I would have called it an alkoxy to name the alkyl and the oxygen. Here we're just naming the alkyl group, so that's methyl. What would this be if it was a carboxylic acid? What would it be named? Benzoic acid. So change the suffix from oic acid to O8. What do you get? Benzoate. This is methyl benzoate. I think only half the class here today was in lab, but we had an experiment where we nitrated methyl benzoate. If I flip this, what becomes my ester linkage? Phenyl. And what becomes my ester? Two right answers here, systematic and common.
Yes.
Ethanoate or ethanoic?
That's where I'm not sure.
So what's the root?
Ethyl or
Eth. What's the suffix? There's no alkene, no alkyne. Ethan. And what's the suffix? Stopper. O8. So phenylethanoate, what would be the common name for this? 2-carbon carbonyl. 2-carbon carbonyl. Acetate. Yeah, so the weird thing here, the O drops again. I don't have acetoic anhydride, I don't have acetoic acid, and I don't have acetoate. The O drops and I just get acetate. Deal? Glad you're happy with it. Good. Good, good. All right, you guys okay if I clear up some space then? Let's look at amides. What do you suppose the amide gets as its suffix stopper? Now for this one, I want you guys to be as uncreative as possible. No, that's a common name for the aminobenzene. That's a good thought, because it's got nitrogen in there. Different functional groups, though.
Heights.
ID.
No, I want you to be less creative. You took
Amides.
AM away. Amide.
Oh.
Isn't that just terrible? Who was put in charge of this stuff?
Yeah, that's the.
Also, we get this, what I'm going to call N alkyl prefix. And that we'll call the amide linkage. And I'll explain what the NN means once we look at an example. This is a pretty common organic solvent. It's referred to as DMF. DMF, though, is a shorthand for its common name. So I want to walk through with you guys the systematic and the common name here. I think we've talked a little bit about the common name for 1-carbon carbonyls, correct? 2-carbon carbonyls, they get the ACET prefix, acetic acetate, acetaldehyde, acetyl chloride. What does the one carbon carbonyl get the common name for? Or common? What is the common name for the one carbon carbonyl? There's only one thing they stuff in you at the end of your life. Form. Form is the prefix for the one carbon carbonyl. Formaldehyde is a one carbon carbonyl that has an aldehyde on both sides. I mean, what is a one carbon carbonyl? It's an aldehyde with something else on the other side that is not a carbon chain. So formaldehyde, formic acid, formate, like methyl formate, ethyl formate, those would all be esters. This is N,N-dimethyl. What that means is that these two methyl groups are not attached to carbons. These two methyl groups are attached to nitrogen both times. Nitrogen is attached to methyl, and nitrogen is attached to methyl. So this is being as repetitive as possible. Do you remember, I erased it, when we have substituents on the same locant, we say 2,2-dimethyl. We don't say 2-dimethyl. We're repetitive as possible. N,N-dimethyl. Both of those methyls are at N.
So if one was like an ethyl, would it just be like N, or would it be N-ethyl and methyl?
Good question. I don't have the answer for you. So let's do a little bit of digging ourselves and see if we can find a compound that matches that. N-ethyl. Well, first of all, what do you think would make the most sense? What would be the best way to clarify that? Let's imagine it's not attached to nitrogen. It's attached to carbons. How do you list that? Do you say 2,3-ethyl methyl pentane?
Should probably be N-ethyl. N-methyl.
You don't like that way, what she's saying?
No, what you said.
Yeah.
There's like two different groups, so I'll say 3 ethyl.
N has ethyl, N has methyl. Good.
I mean, technically, would it matter which side, even if they were different, where it's at?
Drawing it, no. But it matters where that substituent is attached. And the location is the nitrogen.
Yeah, but if they're both on the nitrogen, does it, like, I know normally you, like, say they're, like, 1-methyl, 2-ethyl, but in this case, does it matter on which side of the N it's on, because it could just switch?
Do you mean
Do you know what I'm saying?
Do you mean N-methyl, N-methyl?
Like, no, like, even if one was longer, even if one was, like, ethyl or whatever.
Oh, you would
Like,
still
with the
alphabetize it.
Yeah, but would you need to do, like, N-methyl, N-ethyl, because does it really matter, like, they're both attached to the same N, so does it really matter that you have, like...
So then you're saying we should just call it N-N-ethyl methyl.
I'm gonna say we should, I'm just wondering, like, does it matter where, like, does it really matter?
Well, what I'll say is you're probably not going to have a test question from me that gets that complicated.
Yeah.
But I don't think I understand what you're advocating for.
I know that is what I'm advocating for, but, like, not like I'm not really advocating for it. I'm just wondering if it really matters. I guess.
Change the
Does
compound?
it change? Because it doesn't change the
ethyls-
compound.
Is the ethyl like on top, like, because you have like a methyl this way, so it matter if the ethyl is up here or down here? Like, does that change?
So what you're describing are just different conformations. Would you agree?
Yeah.
You're saying, like, if this was an ethyl chain and this was an isopropyl chain, and this was an isopropyl chain and this was an ethyl,
Yeah.
would that change how you name it?
Yeah.
No, because the name is alphabetized.
So then it wouldn't really matter. You could just technically do N-methyl ethyl and.
Well, the thing about, if you say methyl ethyl, what you're describing is an ethyl substituent that is substituted by a methyl substituent.
Okay.
So it's not just ethyl, it's methyl ethyl,
Uh-huh.
which is actually another way for saying isopropyl.
Okay.
Isopropyl is a 2-carbon chain with a methyl substituent.
Uh-huh.
So I can't say NN ethyl methyl because I only put commas between locants.
Mm-hmm.
And I can't put a comma between ethyl and methyl. And I wouldn't put a dash unless there was another locant.
Yeah.
So we treat the nitrogen just like any other locant position.
Okay.
And we would say N-ethyl, N-methyl, N-methyl, N-isopropyl, or N-N-dimethyl. Both of those methyls are attached to nitrogen. So this is, again, it's a prefix. We oddly didn't need to put a prefix here, but I do want you guys to notice that there is actually a space between all of these. If benzoate was substituted, for instance, if there was a meta-nitro group, then this would become methyl space M-nitrobenzoate. Or if I had a highly substituted carbon chain, I would have methyl, 2,2-dimethyl, 3 I went too high with my first one. 3-ethyl, 2,2-dimethyl pentane. And at the very front of it would just be isopropyl. Isopropyl, 3-ethyl, 2,2-dimethyl pentane. Yeah? Or pentanoate. So the alkyl prefix for the ester linkage really does come out in the front completely. The amide linkage actually gets built in with all of the other prefixes. All right, and I think that's maybe an artifact of the nitrogen being able to have 2 different locants, or be 2 different locants, have 2 different substituents. Okay, so we've got NN-dimethyl. Remember that I told you that the common name for this was DMF. So the common name would be NN-dimethyl form amide, where form there is indicating the aldehyde carbonyl. So that's DMF. How would we systematically name this? Do I need to change anything about the prefix? Do I need to change anything about the suffix stopper? I just systematically need to tell you how many carbons are in there. Oh, okay, NN-dimethyl 1-amide. Anybody would read that and say onamide. Methamide. Oh no, sorry, not necessarily just methamide, because we need a suffix and a suffix stopper.
Methanamide?
Yeah, methanamide. It does sound funny, and it doesn't really even sound correct, if we're being honest.
Because how does that show that there's a carbonyl?
Well, it doesn't necessarily show that there's a carbonyl, other than the amide. Amide tells me that there's
But that's the thing, like,
an amide.
methyl group there.
There is not a methyl group, but this also doesn't have a heptyl group. It has a 7-carbon chain. This doesn't have a methyl group, it has a 1-carbon chain. Can you call a 1-carbon chain a chain? Not really. That's just 1 carbon. But why does it have ane in there? Why is it methane amide and then have alkane modified with amide, methanamide? Because Because what hydrocarbon functional group is in there? Is there an alkane in this parent chain? Is there an alkene? Is there an alkyne? No. So it does seem a little wrong that it has to have methane because there's no alkane. But there has to be a suffix. So its systematic name is methanamide. Anytime that you swap form for systematic, you'll have methane. And maybe that's why they like form better, because technically methane doesn't have an alkane. Why are you calling it methanoic acid? Why are you calling it methanamide? You should be calling it formic acid.
And what about if instead of having an aldehydes and goes to the methyl group?
Well, that wouldn't-
the same.
That wouldn't be called form then.
Well, the not this the other one. The methanamide.
No, this is no longer a one carbon-carbon chain. It's now a...
No, I'm saying taking out the oxygen, just methyl group. When
Oh,
they go
take
the
out the
same-
nitrogen?
No, the oxygen.
There's no... Oh, that becomes trimethylamine. You know, if you take out this, you take out the CO double bond, you don't have an amide. An amide is a carbonyl.
Oh, right.
Yeah. So now you have an amine, 3 methyl groups attached. That just becomes trimethylamine.
I was thinking of. I mean.
Yeah. Okay. Good.
What if you add, like, on the other side, like, a double bond carbon, or, I don't know, like, make it a longer chain of the,
Over here.
off of the carbonyl.
Well, now it's no longer form because form tells me
Yeah.
1 carbon. So if it's a 2 carbon chain, it becomes acetamide or ethanamide. If it becomes a 3 carbon chain and it has the alkene, then it becomes acrylamide. Instead of acrylic acid, the suffix for the acryl group is acrylamide. Before I do nitriles, I think I want to try and clarify these. 1 carbon carbonyl gets the root form. 2 carbon carbonyl gets the root acete. 3 carbon carbonyl with an alkene gets the root acryl.
But is this for systematic or just simple?
So it was adopted by IUPAC in the most dishonest, betrayal, backstabbing, just sellout fashion ever. Right? IUPAC is the international union of pure and applied chemistry. That's not pure. That's accidental. People harvested this compound by crushing up ants. And so they called it ant acid. They called it the acid that comes from ants. And the Greek word for ant was form. So they called it formic acid. That's accidental. Now every time there's a 1 carbon carbonyl, it becomes form. So this is propyl formate. Why? There's no reason. There's no reason. It's not pure. It's a sellout. I'll die on that hill. And I could get fired on that hill. I don't know. Maybe not, but I could get banned from ACS maybe. So I'm not a fan of it, I'll admit. But the only reason that I am emphasizing it Because I'll be honest, this is the first semester that I have given so many examples. That's the first time I've ever written that list up on a board. The only reason I get into it is because I heard recently that the MCAT, the DAT, the PCAT, other entrance exams, they do emphasize the common names. So I do want you guys to be familiar with that kind of stuff, as unhappy as it might make me. Acrylic, acrylate, acrylamide. Acetic, acetate, acetamide. Formic, formate, formamide. There's also formaldehyde, acetaldehyde. Well, I don't think you can have, yeah, you could probably have acrylaldehyde. Okay. We've just got one last one to do. Sorry, I really got carried away there. Nitriles. So, of course, these get the suffix stopper. Nitrile. So, one thing about the suffix stopper having the term nitrile in it. Let's go back to formamide, DMF. What atoms are indicated by the suffix amide? Does the suffix amide tell you about these methyl groups? Does the suffix amide tell you about this carbonyl carbon? Okay, yeah, in a way, it tells you it's a carbonyl. But in the name DMF, dimethylformamide, does the portion amide tell you about this carbon? Or is there another part of the name that infers that carbon? I think you could argue a couple of different ways. I would say that amide is only telling you about the nitrogen. Amide tells you that there's a nitrogen. Form tells you that there's a one carbon there. Even here, dimethylmethanamide. Amide just tells you that there's a carbon, or a nitrogen, attached to a carbonyl, and it's the methan that tells you it's just one carbon. What about nitrile, though? How many atoms are being indicated there by the term nitrile?
One. C that's triple bonded to the N, right?
Seems like it, right? Tells you that you have both the carbon and the nitrogen. So the reason I'm bringing this up, earlier we had acrylic acid, and there was actually a way to call this ethylene carboxylic acid. What we can see from ethylene carboxylic acid is that it indicates these two carbons of the ethylene, and then the term carboxylic acid indicates the remaining carbon and the rest of the functional group. So should we then assume that when we name these when we name a nitrile, does the term nitrile just tell us about the nitrogen, like amide tells us about the nitrogen, even though you would never have an amide unless it was connected to a carbonyl carbon, because something else tells you that the carbonyl carbon is there? Or does the term nitrile kind of act like carboxylic acid in that it tells you the whole functional group, including the carbon? I don't think you'll be happy about this. Maybe I'm just making it too confusing. That term nitrile tells you the same thing as amide. It tells you there's a triple bonded nitrogen. It does not include the carbon unless you have something like this, something that is a substituent. So like methyl nitrile or benzyl nitrile. In those cases, like the nitrile is being prefixed by not having a root. It's being prefixed by a group. So let's do a couple of examples. One of the most common nitriles to use is CH3CN. So the systematic name tells you the two carbons, ethane, nitrile. Now, nitriles don't really look like other carbonyls, is that correct? Because I don't have a double bonded CO group. Instead, I just have a CN triple bond. And yet they're classified as kind of a carbonyl. They're grouped in this whole family, which means that this is a 2-carbon carbonyl. So this can get the prefix ACET. But then with the nitrile, because its suffix starts with an N, think about all the other ones we had. Oic acid, oil chloride, al, one, oic anhydride, O8, amide. They all start with vowels. Most of them are O's, but they all start with vowels. Nitrile starts with a consonant, so you can't just butt up the suffix and modify it with this suffix stopper and have 2 consonants next to each other. So they often change the way that it comes in, and you'll see this called acetonitrile. Or what about cyanobenzene, where I have a benzene substituted by a nitrile? Well, the best way to name this is similar to the best way to name benzaldehyde, benzoic acid. We did have benzoyl chloride. Just take benz, suffix it with the new suffix stopper, but I can't do benznitrile, having those 2 consonants. I think they don't like how it butts up against it. So they add this O, benzonitrile. So should we say that the suffix stopper is nitrile in terms of systematic naming, and the suffix stopper is O-nitrile in terms of common naming?
What would make you call it that instead of cyanobenzyl?
Nothing. Your preference. Yep. Okay. I do want to remind us about the substituent names for these groups. I'm not going to do all of them because I'll be honest, you're not going to see all of them in the semester, and I think it just consumes too much time. Some of them are useful, and we will see throughout the semester. So, when an aldehyde is a substituent, it shows up in the name as oxo. When a ketone is a substituent, it shows up in the name as oxo. I'm not going to get into the acid chlorides or the anhydrides or the esters or the amides or the carboxylic acids as substituents. So we're just going to look then at the nitrile. And I think you guys mostly all know that the nitrile is given cyano as a substituent. One thing that this means that you have to be able to do is prioritize the functional groups. I think I've shown you guys this table before. I want to show it to you again. It doesn't necessarily make sense. So it's not something that I encourage you to memorize in depth, but I do want you to be familiar with some common high priority groups. Do you guys know where I'm bringing you? You don't remember this? Not like the list that I made, not the one that's linked here. If you go down to this free textbook that I've linked, the McMurray text, and you scroll all the way down to the appendices, nomenclature of polyfunctional organic compounds. First, it gives an index of where to find all of the functional groups. I do want to point out, there are functional groups we're not looking at naming. We're not naming the thioesters. Those are basically esters, except instead of an oxygen, it's a sulfur that's linking the carbonyl to an alkyl group. Yeah, that might be it. So here is their list. The highest priority functional group is the carboxylic acid, which means you can't look at the carboxylic acid and say, oh, it's the highest priority because it's the least reactive, because that's not true. There is interesting chemistry regarding the carboxylic acid. We're going to look at how the carboxylic acid can really be converted into a number of different functional groups. So it almost is a central point. The anhydride comes second. The ester comes third. The acid, then the thioesters, which we're skipping. The acid chloride comes fourth. Then the amide. Then the nitrile. It's all over the place. Maybe it has something to do with electronegativity. Maybe it has something to do with somebody had favorite functional groups. Unfortunately, it's not made clear to me. So if one of you is interested in doing some research, please go on ahead and do that. And I do want to clarify, it's not that it's impossible for these to have substituent names. If a carboxylic acid is a prefix, you can call it carboxy. Apparently the acid anhydride does not have one. The ester can be called alkoxycarbonyl. So like methyl carbonyl, benzyl carbonyl, if we were looking at the one I had up before. The acid anhydrides, you can call it a chlorocarbonyl, a bromocarbonyl. Amides, carbamoyl. because it gets that A in there for the amide. Cyano, oxo, similar to how alcohols can be called hydroxies, right? So we're not going to be looking at these complicated structures, although I think some of you have some interesting molecules for your analysis assignment this semester. I would encourage you to take its common name and try to figure out what its systematic name would be. What is the highest priority functional group? What's the parent chain? What would all of the other substituents be? Or maybe even just Google, what is the systematic name of your compound? And you can look into it more. Cool stuff or not cool stuff? No, it's not cool stuff, guys. That was a trick. No, I appreciate that, actually. All right. Why don't we take a quick break? I'm going to put a couple of naming problems up on the board. And then we can start talking about reactions with aldehydes and ketones. I feel like I have shown you guys this before. No, maybe I showed my own in one class. Because this compound I take a little bit of issue with. Substituents almost always have the YL suffix. And in my opinion, well, what they're saying is that the root of this compound is cyclohexane carbaldehyde. And I don't agree with that. Because one of the rules of nomenclature is that you cannot name a carbon that is within a ring with a carbon that is outside a ring. And that's exactly what they did there. Sorry, I'm supposed to be putting on the practice problems. What do you guys find easier? Drawing from a name or naming from a drawing?
Drawing.
Drawing from a name. Okay.
So at least when you're drawing, you don't have to worry about, like, if you're figuring out the right highest priority, it's already been, like, there, and you can still piece everything together without being like, okay, what priority, what order, what alphabetize, all that.
Sure. Yeah, I hear that. That is an alpha symbol. Oh. I made a mistake on this one. I wanted a structural isomer, but it's okay. I'll explain it when we get there.
You still waiting for it?
No, I wanted it meta instead of worked out. I was going for a specific compound. I don't know if you're doing it right.
Yeah.
It's okay. That's learning. I don't think that one starts at 3. Notice how it's butte 3 ion, but this is carbon 1, carbon 2. Do you remember yesterday when I introduced the term alpha and beta? Yeah. Carbonyl carbon, alpha, beta.
So that's why.
Yeah. Except at the beginning. Mm-hmm. No. You're close, but you misinterpreted the suffix. Stopper. Do believe that you have numbered the wrong way. At least for two of the groups. Two of the groups are not in the correct spot. Mm-hmm.
Are these the only ones, right?
Yeah, good. So we would need to have a description of how the methyl is connected to the benzene in relation to the amide. Yes. So you could just put O-methyl, and then it won't be benzolamide. It'll be benzamide. Remember that benzyl actually means benzene plus the carbon coming off.
Oh, okay. So that way you can tell them these two are orthogonal.
Yeah. Yep. And I'll tell you another way that we can name it as well, but that is the best systematic name. Yes, it is. You have too many suffixes. You're only allowed to have one suffix stopper. So you have to pick the highest priority suffix stopper, and then any of the other functional groups that would show up as a suffix need to show up as a substituent prefix.
Can you use toluene to describe that with these? Could it be like
And you would just change the suffix of toluene.
change the suffix of toluene?
Or stopper the suffix of toluene.
So that would just be
Yeah. No, I mean that's a good way to think of it. Well, toluene is TO.
Is that like the prefix part of toluene? What?
Yeah,
Yeah.
yeah,
So that?
yeah.
Okay.
Say that. Say that out loud.
Toluene.
Toluamide. Isn't that a funny? Isn't that a funny sounding thing?
Yeah.
You know, but by saying that, toluene means the suffix is alkene,
Mhm.
and there's no alkene in toluene.
Mhm.
It's an aromatic ring.
Yeah.
That is problematic. Mm. Yes, this one you got. I don't see an alkyne or an ester.
Is that right?
So there should be an ester and an alkyne. You're on to a good start.
No, it doesn't.
That's correct, yeah. But there's no ester.
Oh.
And you didn't need to erase that. You had 3-ine-08. That was correct. Yep.
I think it was.
Oh, I see. Yeah, yeah.
So,
Yes.
oh,
Good. And that's correct. And that's correct. Yeah. That would be one way to name it. There's another way where you can take methyl bens and just call it toluene, and then modify. You can modify toluene to explain that there is toluene and an amide. Toluamide. Who would have guessed that? This is not an ester. It's also not bonded to nearly enough atoms. So remember that O8 implies an ester functional group. And you've got but 3-ine. Ine is the suffix for alkyne.
What's the prefix for alcohol?
What do you think? I think we talked about this. What do you remember? Phenol. Do you remember its systematic name? What if you took the alcohol and you got rid of the carbon group? What would you be left with? I'll give you a hint. It's an ion with a negative charge. And it's just, you got rid of the carbon group, all you have is OH minus. What do you call that? I know you know it.
Hydro.
No.
Okay.
Sodium. It's like the most basic salt, the most basic base. I don't mean the highest pKa base. I mean like the stereotypical base. OH minus. Somebody help her out. Hydroxide. OH minus is hydroxide. Oh no.
It's not working.
Oh no.
But it would just be hydroxy.
Hydroxy or hydroxyl. No. This would be more linear, but that's correct.
Yes. Yeah, I can never draw it that way.
All right, you guys mind if I put them up? What is my root for this compound? 3 carbons. Yep. The suffix would be just ane, and the suffix stopper is either going to be al, all, or oic acid. But the carboxylic acid is the highest priority functional group. So this is given, well, I've got these 3 carbons. One of them is a hydroxyl group, one of them is an oxo group. So that is 2 hydroxy, 3 oxo, propanoic acid. Good. Down here, this gets a little bit more challenging. My root is benzamide, kind of like benzaldehyde or benzoic acid or benzoyl chloride. This is benzamide, specifically NN-dimethyl benzamide. And the benzene is substituted ortho with a methyl group. So this is NN-dimethyl, thank you, diethyl orthomethyl benzamide. But this is not an easy way to name it. So we can also call this compound NN-diethyl toluamide, ortho NN-diethyl toluamide, or maybe NN-dimethyl orthotoluamide.
I put NN-diethyl 1-methyl ortho benzoate.
Well, it would have to be 2-methyl benzamide, and there would be no ill, so it wouldn't be benzolamide. It would be benzamide. It's like you're taking benzene and you're cutting off the ene and giving it a new
So
suffix.
that could be correct.
If you modified it from 2-methyl, or it's not 1-methyl, it's 2-methyl. Benzamide means that this is carbon 1, whereas methyl at carbon 2. Yeah?
So didn't you say that carbon wasn't implied, or is it implied in the amines? The carbonyl carbon, or does it not
You
matter
know what, I
when
think-
it's on a benzene?
I think what we said was it's kind of weird, right? Because if you have amide, you know it's attached to a carbon.
Yeah. But we have to name that part, don't we?
I think by having benzamide,
You don't have to.
you don't have to.
But if it wasn't on a benzene ring, you would have
Then it would be part of the root.
to.
So it is kind of weird because benzene should be just indicating these 6 carbons.
Mhm.
But benzamide is indicating that there's a carbonyl carbon connecting to a nitrogen and a benzene.
Mhm.
Now, I meant to give you meta, NN-diethyl toluamide. Those of us in lab are going to be synthesizing meta NN-diethyl toluamide, which is also referred to as diethyl toluamide. Yeah, that's DEET. So this week in lab, we're synthesizing DEET.
Oh.
And DEET is a phonetic elongation of diethyl toluamide. It should be called DET, but they wanted to call it DEET, so they just added that extra E in there so that you would call it DEET. It's fun. Okay, here my root is 5 carbons. My primary suffix is the aldehyde. At position 4, I have a ketone. And at position 2, I have a benzene ring. Question, why isn't this named in reverse? Why isn't this called 4-phenyl 5-oxo 2-pentanone? Why did the aldehyde get named instead of the ketone? Am I suggesting that the aldehyde is a higher priority functional group than the ketone?
Yeah.
Yes and no. They're actually tied with each other. But if they're both in a molecule, then the aldehyde is always going to create a lower locant set if it gets named first. Because the aldehyde is a terminal carbon. So you start there at this terminal carbon and then name from there. So it's actually very similar to the alkene and the alkyne. Alkenes and alkynes are tied with each other. And if they're both in a molecule and they have the same locant, then you just go alphabetical. All right, now this was meant to trick you, meant to push you a little bit, because yesterday we talked about the alpha-beta positions regarding ketones. Alpha is positioned next to the carbonyl carbon. So what I have is a 4-carbon chain with an alkyne and an ester. So I'm going to start by drawing my ester. Here's carbon 1, 2, 3. 3 starts my alkyne, and there's my 4-carbon chain. At the position alpha to my ester, I have a cyano group. Which can be drawn a lot of different ways. You could just write CN, you could draw the C and N, or you could draw it like this. Now the O8 tells me that I have an ester, but what is on the other side of the ester actually comes at the very beginning of the name. Methyl. Alpha cyanobute 3-inoate. Woo. Good stuff, right? Okay. Yeah, I did spend a lot longer on nomenclature than I wanted to, but as it turns out, I really like nomenclature. It's a very common trope that people hate IUPAC nomenclature. I don't. So if I could teach a whole semester on IUPAC nomenclature, I might. We didn't quite get into the reactivities of aldehydes and ketones, and we have a number of reactions to learn about. We're going to look at when aldehydes and ketones are hydrated, when they react with water. We're going to look at when aldehydes and ketones are reacted with alcohols. They're going to form a new functional group for us called hemiacetals and acetals. We're going to look at when ketones and aldehydes react with amines, and we're going to form 2 functional groups for the first time, imines and enamines. And of course, we're going to review some reactions where aldehydes and ketones are reduced, where aldehydes and ketones are synthesized. We're going to learn some new reactions where we can oxidize aldehydes and ketones as well. So I think what I want to just wrap up with today is just give you an overview of a couple of the new functional groups that we're going to look at. New groups coming. Please remember that these are generic. Take a second to get them copied down. So this first group, I think you guys would all agree, is a diol. That's a 2-alcohol functional group. But more specifically, they're located on the same carbon. So we're going to refer to this as a gem diol. Gem, have I introduced this before? Referring to the star sign, geminal, meaning twins, attached to the same carbon. We could call this a gemetherol. Nobody calls it that though. Instead, this is referred to as a hemiacetal. Now, notice the ACET group in there, plus the AL group. That means that this may have been named after a 2-carbon carbonyl aldehyde. And some people refer to this as acetyl, but I pronounce it acetal because it has the al of the aldehyde in there. Also, acetyl is already used, so I don't want it to be confused. Hemi means halfway. So what is the full acetal? Well, if the etherol, right, this is a gem etherol, because I have both an ether and an alcohol attached on the carbon, is not a diol and not a diether, then the acetal must be my gem diether. So acetals, geminal diethers. Hemiacetals, halfway between a gem diol and an acetal. When a nitrogen is double bonded to a carbon, this functional group is called an imine. When a I'm having a hard time giving you exactly what the best name for this next group is because I think it's getting a little more complicated. But we can think of this next group when a nitrogen and an alcohol are attached like this. This is a hydroxylamine. We can come back if I find a better way to refer to that name. It might be called an oximine. Oxime. I'm just not a big fan of that term. Oxime. Maybe, yeah. Now, when a nitrogen is bonded to an alkene carbon, we call this an enamine. That is an amine that's attached to an alkene. Okay, thank you guys. I'll see you tomorrow morning, and we'll start looking at our reactions to make these functional groups from aldehydes and ketones. There's going to be 2 mechanisms from this section that will show up on your homework and will show up on the final exam.
So the homework